Alright, moving on to question 5 of the Carbonyl tutorials. Question 5, it's a chemical test question together with a deductive question. Okay, so we take a look at the question. We have 3 different compounds of the molecular formula C8H8O, which gives a precipitate with 2,4-DMPH. So if you recall 2,4-DMPH, alright, what we're testing for? We're testing for aldehydes and ketones. Alright, so which means these 3 compounds are both aldehydes or ketones. Right, they can be reduced by lithium aluminum hydride in dry ether. Right, so this is nothing new. We know that aldehydes and ketones can be reduced to form the corresponding primary and secondary alcohol. So if it's aldehyde ketones, you get your primary and secondary alcohol. Okay, with the molecular formula C8H8O. Okay, so let's take a look. We're supposed to look at the structures and explain how they can be distinguished from each other. And the question specifically mentioned that the isomerism does not arise from a difference in the orientation of substituents in the benzene ring. Okay, so let's take a look at how then do we come up with the structures. So the structures is required and we need to give reasoning. So basically you need to write your deductive statements. So you can see that I've numbered 1, 2 and 3. There are 3 sets of information that we can gather. So let's take a look at info number 1, C8H8O. So in this case, the carbon to hydrogen ratio is comparable, close to 1, it's 1:1 ratio in this case, alright. So in this case, and the number of carbon atoms is more than 6. So we can therefore conclude all 3 compounds contain a benzene ring. Okay, and just now we mentioned the reaction with 2,4-DMPH. So to write deductive statements, we basically write the type of reactions followed by the deduction about the functional group. So all 3 compounds undergo decondensation with 2,4-DMPH to form an orange PPT. Right, all 3 compounds are aldehydes and ketones. So as mentioned again, the type of reactions, okay, followed by the functional group or structural group. In the case of aldoform, we will write either the beta alcohol or methyl ketone. In the case of other functional group tests, basically you state the functional group that's confirmed from the test. Okay, and in the third point, reduced by lithium aluminum hydride, this is already given, so it's reduction, and they will form your alcohol, primary and secondary alcohol. So given that the molecular formula is C8H8O and there's a benzene ring, right, this makes the structure quite easy to obtain. Okay, so let's take a look at this question. We have these 3 compounds. Alright, so we have a benzene ring with C8H8O, which means after drawing a benzene, I have 2 more carbons to place. Alright, 2 more carbons to place. I can consider the first scenario where I have a C double bond O, and then 1 more carbon. I can put a CH3. And what do I get? I get what we call a ketone. Alright, so a ketone in this case. Okay, a ketone in this case. So that's going to give a positive 2,4-DMPH test. Okay. Now, instead of having a ketone, I can now change the position of double bond to be at the terminal position. So for example, I can have a case of CH2, C double bond O, H. Right, so you can see it's just isomers. I'm shifting the C double bond O to the carbon number 1. And that's where I get an aldehyde. Right, an aldehyde. So you can see this is the aldehyde functional group, CHO. Okay, and this aldehyde is not joined to the benzene ring directly, so it's what we call an aliphatic aldehyde. Okay, now last but not least, instead of having an aliphatic aldehyde, I can also have an aromatic aldehyde. So the constitution is this: instead of having a CHO that's away from the benzene ring, how about let's put a CHO aldehyde group directly next to the benzene ring. And then now the question is, where do we put the remaining carbon? So you can have a carbon CH3, for example, at a 1,2 position if I want to. So that's 1/3 possible isomer. In this case, we get an aromatic aldehyde. Now, so take note for C itself, because there is not enough information in the question to tell you where the position of methyl group is. Right, we can have either the 1,2 position. Okay, in this case, the 1,2 position aldehyde given the position number 1. Alright, and then or we can have the 1,3 or the 1,4. Okay, so in this case there are 3 possible structures. ketones, aliphatic aldehyde, and aromatic aldehyde. Now, of course, when you propose a structure, it's important that you check with what you propose against the molecular formula. So importantly, let's count the number of carbons. There's 8 carbons, that's for sure, 1 oxygen. Alright, now the hydrogens. So we have 3 here, 4, 5, 6, 7, 8. So this is correct. Let's check the other one. I have 1 H here, 1, 2, 3, 4, 5, 6, 7, 8. That's also correct. So last one, 1, 2, 3, 4, 5, 6, 7, 8. Alright, so in this case, all compounds fulfill the molecular formula, and all of them fulfill the conditions that they are all either aldehydes or ketones. Alright, and therefore, these are 3 possible structures. Okay, now once we get these 3 possible structures, you can notice that we have a ketone, we have an aliphatic aldehyde, and we have an aromatic aldehyde. The second part of the question requires us to propose chemical tests to distinguish them from one another. Okay, so let's take a look. We can this is pretty much similar to what we have done in experimentary planning. So we have a ketone, an aliphatic aldehyde, and an aromatic aldehyde. Alright, first consideration, I can separate the aldehydes from the ketone. Alright, so what is the reagent that we can use to test for your aldehydes? So for example, you recall Tollens, right, reagent together with warm. Alright, test number 1. Alright, we'll be able to distinguish the aldehyde. Your aldehyde will give a positive Tollens reagent test in which we have a silver mirror, and your ketone will not. Alright, ketone will not and get a silver mirror, so no silver mirror form for ketone. So now that I've distinguished A from B and C, so ketone is identified. Alright, so silver mirror, we have your B and C. For your no silver mirror, we have our A. So in this case, how do I distinguish between an aliphatic aldehyde or an aromatic aldehyde between your B and C? So now in this case, to distinguish them, I can consider doing my Fehling's reagent or filling solution, and I warm. So Fehling's reagent is to test for aliphatic aldehyde. So an aliphatic aldehyde, in the case of B, will give a brick red PPT, whereas for C, no brick red PPT. Your aromatic aldehyde will not give a brick red PPT for C, and that's how I distinguish them. So Tollens followed by Fehling's. Alright, it's a simple chemical test. Alright, so in this case, there are quite a number of different options. So let's take a look. So one way is doing Tollens reagents. Tollens test first to test for the aldehydes, then followed by Fehling's to test for the aliphatic aldehyde. That's one way. Alternative, I have another solution. I can consider doing iodoform test first. Why can I do iodoform? Because in the case of the ketone, right, alright, I have the CH3CO, the methyl ketone group, and this will give a positive test with my iodoform, iodine in NaOH with heat. So alkaline iodine aqueous. Alright, so ketone is identified. Now, for the aliphatic aldehyde and aromatic aldehyde, both will give a no pale yellow PPT. So to distinguish again aliphatic and aromatic aldehyde, I can consider adding Fehling's reagent and heat. As mentioned earlier on, aliphatic aldehyde will give a brick red PPT, aromatic aldehyde will not give a brick red PPT. Okay, so that's another alternative. So only tests, like I mentioned, can do either test 1 can either do Tollens, or you can also do iodoform. Okay, another alternative is to also use dichromate. Because why? So if you look at dichromate, your ketone cannot be oxidized, but as your 2 aldehydes can be oxidized. So your ketone will give a negative test result, whereas your B and C will give a positive test result, leaving both your aldehydes, and then you distinguish them by Fehling's. Okay, so with that, I'm done with question 5. Okay, so take note, when you guys write observation, how do we write observation? Remember, we have to write the observation for both the positive test as well as the negative test. For the positive test, most of you have no issues. You guys will be largely able to write the correct observation if you remember your book well. But for the negative observation, please do not write no visible observation. Alright, that's not accepted. you always write the negative observation. So whatever silver mirror is the expected observation, then you write no silver mirror form. If orange acidified potassium bicarbonate turns green, so in this case, the bichromate cannot oxidize your ketone, so it will remain orange. Okay, that's it for question 5.